Now we'll see what is the mesh current and what is the branch current. Okay, so to explain this one, I will take one circuit like voltage source V1 and voltage source V3. Then the circuit will be like this. So like this we have the circuit. Okay, and here node 1, node 2, node 3, and here you can assume reference is there, and it is R22, it is R23, it is R12, it is R13. Like this we have the circuit. Now while doing the mesh analysis, what we need to do in the sense, once you have identified the meshes, what are the meshes you can able to tell here? This is the mesh we can consider. Okay, and this is one mesh, this is the second mesh, and this is the third mesh. Three meshes we have identified. Okay, so after identifying the meshes, we need to assign the mesh currents. Okay, so that part also I will do. So because we have identified three meshes, three mesh currents we can take in the clockwise direction, or you can take anti-clockwise direction. I'm following clockwise directions. So it is a mesh 2, in that current is I2 in the clockwise direction, and it is a mesh 3, current is I3 in the clockwise direction. Now you focus on mesh 1. For example, it is the mesh 1, it is mesh 2, it is mesh 3. Okay, now you focus on mesh 1. In the mesh 1, what are the elements we have? In the mesh 1, we have voltage source V1, resistor R12 and resistor R22. Okay, but you can see in voltage source V1, it is related to only mesh 1. It is not common to any other mesh. So in the voltage source V1, because it is related to only mesh 1, it is not in between any two meshes, so that the mesh current is equal to the branch current I1 only. That means the current through V1, the current through V1, you can tell is directly the mesh current. That means the branch current is equal to mesh current. Branch current is equal to mesh current when the branch is related to only one mesh. Okay, when branch is in only one mesh. In this case, that is mesh 1. But if you see R22, R22 is available in between mesh 1 and mesh 2. Is between mesh 1 and mesh 2. Mesh 1 current is I1, mesh 2 current is I2. But what about the branch current that is passing through R22? So IR22 is equal to, how to tell that one? It is the difference between the two mesh currents. Difference between two mesh currents. That means I1 minus I2 we have to take. Okay, what is the reason for that? Why do we take a difference? If you see this R22 resistor, and if you want to find the current passing through this one in this particular direction. So this is the direction I have taken for R22. In this direction only current I1 is going, but if you see I2, this is going in the opposite way. So that the total current which is passing through the R22 from node 2 to ground is I2 minus I1. Okay, sorry, I1 minus I2 we have to take. Because I1 is coming from node 2 to ground only, but I2 is going from ground to node 2. So this is exactly opposite to I1. So that the difference between the two currents we have to take, that is I1 minus I2. Then you will get the current that is passing through the R22 from 2 to ground, from node 2 to ground. So what is the conclusion here? The branch current is equal to mesh current. It is possible when the branch is related to only one mesh. But branch current can be the difference between the two mesh currents whenever the branch is related to or when the branch is common to those two meshes. Here, another point I want to highlight. For example, again I'm drawing the circuit. And previously I did not take any resistor in series with the V1. You can take that also. Now also I am taking one resistor which is in series with V1, the V3. And this is the resistor common to these two meshes. And one more resistor is connected from node 1 to node 3. So like this I have taken, it is the ground. Okay. Then I have given the names of the resistors like this. It is R11 for example. It is R12, it is R22, it is R23, it is R13. Then I have given the mesh currents in the clockwise direction. Like this. Okay. Then what I told, I R11 is equal to I1 alone, because R11 is related to only mesh 1. So in that case, mesh current is equal to branch current. Okay. And current through V1 is also simply I1. What about current through R22 means I need to take the difference between the two currents I1 and I2. That means I1 minus I2 I will get. Now these three, and one more thing also we can write, R12 also we can take. IR12 is equal to, can you tell the current related to R12? Current related to R12 is I1 minus I3 I have to take, because this branch is related to mesh 1 and mesh 3. So that I have to take the current differences between mesh 1 current and mesh 3 current, that is I1 minus I3. So these are the currents I have written with respect to mesh 1 alone. This is the very, very important point. Now, you tell the currents related to mesh 3 branches. Okay, mesh 3 is involving branches R12, R23 and R13. Then the current related to R12 is equal to what it will be? Since it is related to mesh 1 and mesh 3, the current related to this one is the difference between the two mesh currents, that is I3 minus I1. Here you have to concentrate. Previously I have given IR12 is equal to I1 minus I3. But now I am telling IR12 is equal to I3 minus I1. Here the people will confuse. What is the reason for this? When you are looking for mesh 1, or when you are writing the KVL in the mesh 1, you need to assume that you're writing the equations related to I1 only, because that is related to mesh 1. Then you need to think I1 is greater otherwise. Okay, so you are looking in the clockwise direction in the mesh 1, but when you write the equations related to mesh 3, you are writing the equations by taking the direction clockwise in the mesh 3 alone. Okay, so for example, you are looking for mesh 1, again I am telling, in mesh 1 again I am talking with respect to R12. In the mesh 1, the current is passing in the clockwise direction like this. I1 through the R12 is available in the same direction only, in the clockwise only. That means that is coming from 1 to 2. With respect to that one, you have to move from 1 to 2 only, because that is the clockwise direction. I3 is moving from 2 to 1. That's why it will become minus I2. I3, minus I3. Okay, actually I3 is going from 2 to 1. I need from 1 to 2 only, because I am looking in the mesh 1 only. So with respect to mesh 1, how to take I3 from node 1 to node 2 means I know that is minus I3. So in that criteria, I got I1 minus I3. But when you are reading equations with respect to mesh 3 in the clockwise direction, the I1 will be flowing from, actually it is from 1 to 2, because I need to look from a mesh 3 point of view, so that it is moving from 2 to 1. That is minus I1 I have to take. So I3 minus I1 I have to take when you are writing the equations with respect to mesh 3. And when you are writing the equations with respect to mesh 1, you have to take I1 minus I3. Okay, so this is what you have to consider. If this point is clear to you, then further you can able to do very easily.